Welcome. This lesson we're going to be looking at polynomials and just introducing some of the language that you're going to be using during this topic. So the first thing to note is that poly just means many, and we're going to be doing a lot of the skills you've done before with your function notation and mainly dealing with linear and quadratics in those chapters, but now we're going to be looking at going to many higher powers of x. So the language used to describe polynomials is we refer to it by its degree. So the degree of the polynomial is denoted by the highest power of x. So for example, if I had the function f of x is equal to 3x cubed plus 2x minus 5, then we'd say that this is a third degree polynomial, or a degree 3. And often we'll use the short term cubic. Likewise, if we had a degree 1, that just means that anywhere in the function, the highest power of x is 1. So, for example, f of x, we could have 2x minus 3. And they're always going to be linear. If we had a degree 2, it means that the highest power of x must be 2. So let's say we had 3 minus 4x squared, which is our quadratics, and so forth. And that means that we can keep going higher and higher. So let's say, alright, we've got our 3, that's our cubics. We could go 4, 5, 6, dot, dot, dot. Let's say we had a degree 7. Alright, so degree 7 just means that the first, or the highest power of x is going to be 7. The rest, doesn't matter how many terms you have, plus, let's say there's a squared. We don't have to have a term for every single power of x, we just look at the highest power, and that tells us degree. So that's a degree 7, and for example, a cubic, we might have x cubed plus 2x squared minus 5x plus 6. So when describing a polynomial, we can use that term degree. Later on in the topic, we'll look at what the graphs look like, and we can actually tell what they might look like in terms of their shape, based on whether their degree is even or odd, but we'll get to those skills a little bit later. So for now, the degree, the highest power of x. Some of the other types of language you'll come across is we have the leading term. So to make it easier, we always list the powers of x in their descending order. So if I had a function f of x, so let's say it was 3x squared minus 4 plus 6x to the power of 5, I could rewrite that as, or reorder. So I'm not changing what it equals, I'm just putting the terms in a different order. And I remember, always take the sign out the front. So that's going to be positive 6x power 5, that's a minus 4. So I'm going to put them in descending order. So I'm going to put my highest power of x first, 6x to the power of 5. The next one is a plus 3x squared minus 4. So the leading term is that highest power of x there, the one that goes at the front. That's my leading term. Okay. Now, let's have a look at how we can do our operations with polynomials. So, we've got the language to describe them. Let's look at a couple examples where we've got two separate polynomials. So, we can complete some operations with polynomials. Now, if we add, subtract, multiply, or divide two polynomials together, we're going to get another polynomial as the answer. So, for example, I'm using f of x here. Let's say f of x equals to 2x squared plus 3x minus 5, and g of x can equal, let's say, x plus 3. So, here's two functions, f and g, and if I wanted to, I could add these two polynomials together. So that means that I just get all of f of x, which is 2x squared plus 3x minus 5, and I get all of g of x, and I add that on, plus 3. Then, to simplify, just collect your like terms. 2x squared, there's no other x squared, so 2x squared is my leading term. 3x plus one lot of x, I have plus 4x, minus 5 plus 3, I get minus 2. So that's what f of x plus g of x equals. We can also subtract them. So let's say I had f of x minus g of x. Then I take all of my f of x, just like I did in that first example, 2x squared plus 3x minus 5, and I subtract all of g of x. Now, I'm going to put g of x in brackets. Okay, for this one, it won't matter too much, but if I had a minus 3 in there, I'd be subtracting a negative. So if I put it in brackets there, I know that I'm not going to get caught out if I'm subtracting a negative. So 2x squared, again, that's my leading term. I've got 3 of x minus x, so now I have plus 2 of x. Negative 5 minus 3 gives me negative 8. Okay, and let's look at one last one. Let's try and multiply these. And I'll say f of x multiplied by g of x. Now, you can also write that as just f of x, g of x. There's nothing written in between it. Just assume it means multiply. So, all of f of x, I'm going to put in brackets 2x squared plus 3x minus 5. And then I'm multiplying it by x plus 3, which is g of x. Now, when we had two linear factors multiplying to each other, or we had two brackets with just two terms inside it, we used a technique called FOIL. So multiply the first, the outside, the inside, and the last terms. As with most things in this chapter, polynomials, we're using the same skills. We're just going to the higher powers. So now we've got 3 terms in a bracket multiplied by a bracket with 2 terms in it. So we just want to multiply each of those terms by the partner one in the bracket here. So everything in the first term, everything in the first bracket is going to get multiplied by everything in the second bracket. So I'd have to go 2x squared times x. So I'm going to get 2x cubed, and then 2x squared times 3, I'm going to get plus 6x squared, and then work your way down the bracket. The next term, 3 of x, I'm going to multiply that by x, and then by 3. So 3x times x gives me plus 3x squared. 3x times 3 gives me plus 9x. And then the last term, which is a minus 5, I'm going to times that by x and times it by 3. So I get minus 5x minus 15. Now we can simplify this. We've got 1, 2, 3, 4, 5, 6 terms. And notice that I had 3 terms in this bracket, 2 terms in this bracket. So I should, in my first line of working out, get 6. So I know I haven't missed anything. It's a nice little way of checking. If I had 4 times 3, I'd have 12. But some of these will cancel off. You can see we've got some like terms in here. So 6x squared and 3x squared. And I've also got 9x and minus 5x are like terms. So 2x cubed stays, plus 6x squared plus 3x squared gives me 9x squared. Plus 9 minus 5 would give me plus 4x. And then I've got minus 15 at the end left over. Okay, so polynomials, we're still using function notation. We're just going to be going to higher powers of x than you've probably dealt with before. But the language and the skills are consistent throughout. We will look at graphing and how to find equations and how to factorize and do some long divisions down the track. But for now, just have a practice of using the operations plus, minus, times, and divide with 2 separate polynomials. All the best.